Hello students, we are again going to study the same chapter, that is motion, and this is the fourth part of the video. If you haven't seen the previous one, go through the previous videos. Today we are going to again continue with the graphical analysis of motion, but today we will be talking about velocity time graph, okay, and for uniform motion and also for the non-uniform motion. Okay, so here in velocity time graph, the first thing that comes into our mind is, or we can say is, what is a velocity time graph? There is the variation in the velocity with time for an object moving in a straight line can be represented by the velocity time graph. Okay, in this one also, the velocity is taken to be in y-axis and time is taken to be in the x-axis, and the product of the velocity, product means the product of the velocity and time, okay, it gives us the displacement. Okay, this is the formula for the uniform velocity. And if a body moves with a constant velocity, then the velocity time graph of the body would be straight line in parallel to the time or the x-axis, because this is called as the x-axis and this is called as the y-axis. So whenever there is a constant velocity, okay, whenever there is a constant velocity means there is no acceleration. Constant velocity means no acceleration. Okay, and when there is acceleration, that means there is the variation in the velocity. Okay, so this is how the graph looks like. This is the velocity, this is the time, and this is how in like 6 seconds, or we can say in 5 seconds, it traveled 40 kilometer per hour, and again in 11 seconds it was in 40 meter per second, sorry, 40 meter per second. So that means there is no change in the velocity. When there is no change in the velocity, that means there is no acceleration. According to the velocity time graph, you will be getting a straight line. As I told you, you will be getting a straight line, and from this graph itself we can determine the distance traveled by the body. For example, if we want to find out the distance traveled between A and B, okay, and how much velocity it was 20 kilometer per hour. Okay, in 20 kilometer per hour, if the car was moving, so between A and B, what was the distance? If you want to calculate, how will you calculate? It will be calculated by this formula: V is equals to distance upon time, yeah, displacement upon time. So if you have to find out the distance, so according to the distance, this formula will be like done: V into T. Here V is 20 kilometer per hour. Okay, and how much distance it traveled? AC, okay, this is the distance, or BD, because both are equal. We can take any either of the one. And in time, if we talk about, we have to minus T2 minus T1. First it started at T1 and it ended at T2. So T2 minus T1, that can be written in what form? DC. Okay, in DC form. So if we put it in the formula, then what we can write? S is equals to V into T. This can be written as S is equals to AC into CD. And when we will put the values, okay, when we will put the values, we will get it. So actually AC, can you see over here? Actually AC and BD, both of them are forming a rectangle. So once you will apply the formula for area of rectangle, then you will get the value of the distance. Okay. In the same way, if I ask you to find out the distance of the shaded region, so what do you have to do? You just have to add the area of rectangle. Why? Because this is rectangle. This shaded region, if I am shading this one, this is a rectangle. Okay, area of rectangle plus area of, what is this? This is a triangle. This is area of triangle. When we will add these two, then we will get the total distance, or the or total the quantity of the shaded region. And what is the area of rectangle? Area of rectangle is length into width or breadth we can say. Okay, and what is the area of triangle? Area of triangle is half into then base into height, you can say. So by applying these two formula, you can get the value of these shaded region. Again, same thing with the diagrammatic representation. I'm telling you, the area under the velocity time graph is the distance. Okay, the magnitude of displacement of the body, you can also say. Okay, so distance traveled by the body between A and E, between A and E is the area ABCD. A, B, C, D, E. Okay, so we have to calculate all those things. So how we can calculate? S is equals to area ABCDE. Okay, area ABCDE can be written as area of rectangle ABCD, this part. Okay, and area of triangle, that means this part. Can you see this one? This part. If you will add the area of rectangle this part and area of triangle this part, by applying the formula, you will get the value of S. Okay. Till now we studied about the velocity with uniform acceleration. Okay. Now we are going to study about velocity with non-uniform acceleration. Non-uniform acceleration means non-uniform acceleration can be in deaccelerated motion or non-uniform acceleration. Okay, non-uniform acceleration means there might be the change in the speed. It can be slow or fast, slow or fast, slow or fast. When the speed is slow or fast, we will get the graph like this. And when there is completely uniform if there is uniform decrease in the velocity, okay, when there is uniform decrease in the velocity, so that means we will get this graph. That means it will be coming down, it will be sloping down. Okay, so this is how it has said, whose velocity decreases with time, the graph is straight line, the decreasing slope. Okay, and when there is velocity in non-uniform motion, the graph shows different variations like this. So that's it all for today. We'll be continuing our topic in the next video.